folks. So in our next part, when we're stating the restrictions here, hopefully you had a chance to go through these. If not, pause the video and give them a try first. But we're going to kind of jump into it and go through the restrictions for each one here. So in my first one, remember everything under the square root can't be a negative. I can't take the square root of a negative value. So that means that for my first one, basically 9 minus 2y has to be greater than or equal to 0. Okay, this expression can't be negative. It's got to be at least 0, but it has to be bigger than 0, or it could be bigger than 0 too. So that means that 9 is greater than or equal to 2y. I'm going to add 2y to both sides. And then that means that 9 over 2 is greater than or equal to y. Or another way I could write that is y is less than or equal to 9 over 2. Okay, so there's my first one. In my next one, 3x has to be greater than or equal to 0. Well, that means that x has to be greater than or equal to 0. If I divide by 3 on both sides, I get my value or my restriction for x. So x is greater than or equal to 0. In the one below that, x minus 11 has to be greater than or equal to 0, so it looks like x has to be greater than or equal to 11. In my next one over here, x plus 7, so same thing, x plus 7 has to be greater than or equal to 0, so that means that x looks like it has to be greater than or equal to negative 7. 2x plus 5 is greater than or equal to 0, 2x is greater than or equal to negative 5, means that x looks like it's greater than or equal to negative 5 over 2. So I'm running through the same process each time here. I'm setting the restriction and just saying it has to be bigger than or equal to 0. Now here, this one's unique because here we have a cubed root. And I can actually have the cubed root of a negative number. If I take the cubed root of negative 8, really, this is really just the same thing as saying the cubed root of negative 2 times negative 2 times negative 2, and so really the cubed root of negative 8 is actually just negative 2 as an answer. So whenever I have odd number powers, I actually can take the square root of this. So in this case, x can actually be any number, has no restrictions. X is just in the set of real numbers. Okay, so anytime we have an odd number power, an odd number root, that means that x can really be any value because I can actually take the cubed root of negative answers. Same thing if it was 5, 7, 9, it all works out the same way. An even number root, however, still can't be negative. So x plus 1 still has to be greater than or equal to 0, and x still has to be greater than or equal to negative 1. So I've got all of my restrictions laid out, and hopefully that makes a little bit of sense, kind of seeing the odd and even numbers for your roots. Alright, so moving on in our examples. So for example 4, we'll go through the same process. I'll get you to pause the video, give it a try. This one obviously is a little bit more involved. You see there's 2 roots here, but pause the video, give it a try, and come back when you're ready. Alright, so we start this one off by combining what we can. So I can combine the numbers together here, right? There's no stopping that part. So 3x is equal to 5x plus 4 plus 5 minus 7. Okay, all I did was move the x over, or sorry, the 7 over to the other side. So the root of 3x is really then equal to the root of 5x plus 4 minus 2. Okay, that's my starting spot. Now, I have to square this because that's what we did in the last examples, and that's the only way to break this square root idea. Now, when I square these, it doesn't matter which one we square first, so let's just kind of check and see what happens if we square what we have right here. So if I take a look at my first term, okay, I'm going to square this, and then remember I have to square everything over here. So if I square this, that's okay. The square and the square root's just going to give me a 3x. But over on this side, remember this is like saying if it's squared, that's 2 of them. So 5x plus 4 minus 2. And then remember we said there's 2 of them. So root 5x plus 4 minus 2. And now we're left actually foiling our second term out. So 3x is equal to, and now I'm going to have to multiply my first two together. Well, that's okay, because that's just going to eliminate the square term. It'd be root 5x plus 4 times root 5x plus 4. That's just 5x plus 4. Now I have to do my outside terms, so that's minus 2 root 5x plus 4. Then I have to do my inside terms, which again is minus 2 root 5x plus 4. And then I do my last two terms, which is just going to give me plus 4. So 3x is equal to 5x plus 4. Now if I combine these together, because they're the same under the root, 5x plus 4, I'm going to get minus 4 root 5x plus 4, and then plus 4 at the end. Now, what I would like to do here is I'd like to be able to start to combine things together. Like I can see, for instance, here I actually have a plus 8 pop out here. So, because this one's negative, I'm going to move it over to this side and make it positive, and I'm going to take 3x and I'm going to move it over here. So, when I'm done this step, I'm going to have 4 root 5x plus 4. So all I'm doing is I'm adding this to the other side. And then I have a 5x. I have my two 4's added together. That's plus 8. And then I'm going to take this 3x and I'm going to subtract 3x from both sides, minus 3x. So now 4 root 5x plus 4 equals 2x plus 8. Now I'm going to go through and I need to square this yet again because I need to break the square operation. And this is something that's a little bit tricky to do to start off with, just because sometimes we don't think that we have to do the same thing twice here to solve. So remember that this square actually applies to both terms. It applies to the 4 and to the root. So that means here I actually have 16 times 5x plus 4, right? The square and the square root still cancel each other out, but 4 squared is 16. Equals, and then this one is 2x plus 8 twice. 2x plus 8. So 16 times 5, that gives me 80x, and 16 times 4 is 64. Equals 4x squared plus, looks like 16x and 16x. So outside and inside terms, and then my last term is 64. Now, after that, looks like I've got a 4x term over here, okay? I've actually got a 64 on this side already too. Oh, and I forgot the x term off of here. So I'm going to take everything and move it over to this side. 4x squared plus 32x plus 64. That takes care of all these. Minus 80x minus 64. So I've taken this, moved it over to the other side, there it is. Taken the 80x, moved it over to the other side, there it is. And then now I can see it's 64 positive, 64 negative, they're going to cancel each other out. So 0 is equal to 4x squared. 32 minus 80 looks like it gives me 48. So minus 48x. Now I've got two separate terms here. If I factor out a 4 from each one, because I see 4 can go into 48, and I take an x out, I'm looking for the common factors here, then what it looks like is left over is x minus 12. So I can see from this that for x equals 0, that means that x can be 0. And I can also see from this that x can equal 12. So it has two different answers, right? If x is 12 here, that makes 0 here. 0 times this is 0, so that holds true. And 4 times 0 is 0. And then 0 times anything inside that bracket is still going to be 0. So I've got two different answers here that I can use. So using these two different answers, I should be able to go through and verify that these two answers are either good solutions or see if one is an extraneous root or not. So if I go through and check and see, so let's check them. Okay, so remember we're going to verify left-hand side to right-hand side. So the first one is 0, which makes this kind of nice. So 7 plus the root of 3 times 0 equals 5 times 0 plus 4 plus 5. Well, 3 times 0 is 0, and the root of 0 is 0, so this one's just 7. And then 5 times 0 is 0, and this is really the root of 4. Root of 4 plus 5, which is just 2 plus 5, and 7 equals 7. So 0 checks out. That's a good solution. Now if I try my next one out, now what we're trying out is 12. So 7 plus the root 3 times 12, does that equal the root of 5 times 12 plus 4 plus 5? So 7 plus the root of 36, does that equal, and then I've got the root of 5 times 12, that's 60, and 60 plus 4 plus 5, that's 7 plus 6 on this side. Does that equal the root of 64, that's 8, plus 5. Well, 7 and 6 make 13, and 8 and 5 make 13, so I've got another good solution. So both of these are valid solutions to this question. I've also got restrictions here where x has to be greater than or equal to 0, okay, as my restriction. So maybe you've noticed at this point that there is another one that's here for this one. If it already states it in the question, then we don't have to go and solve for it afterward. So it's already stated in a restriction, so we're good there. So we've found a solution and we've checked it. So we've got one more left to go through to solve. And again, what I'll do is I'll get you to pause the video, try it out on your own, and then come back when you're ready. Alright, so hopefully, again, you've had a chance to kind of at least attempt the problem and see how you can make out on it before kind of seeing the answer here. So with this one, we're going to kind of go through it the same way. So I'm going to take the 2m minus 1 and I'm going to move it over to the other side. I could very easily have just taken the 3 plus m and did the same thing. I'm just going to keep the 3 plus m just because it comes first here. Really no other reason. And I'm going to subtract this whole root. So basically everything here is going to go over to the other side. So 5 minus the root of 2m minus 1. Then I'm going to do that square step. So square and square. So the square and square root term is going to cancel out. So this just gives me 3 plus m on this side equals, and then remember there are 2 of them now on this side. So 2m minus 1 and 5 minus the root 2m minus 1. So 3 plus m equals 5 times 5 makes 25. I'm going to FOIL this out now. Outside terms looks like it's minus 5 root 2m minus 1. And then inside terms look like another minus 5 root 2m minus 1. And then my last two terms look like plus 2m minus 1. Because these two are going to be squared, and that's going to eliminate the square root. So let's tidy this up a little bit. 3 plus m is equal to, looks like I've got 25 minus 1, so that's 24. 2 minus 5, root 2m minus 1, so that's minus 10, root 2m minus 1, plus 2m. So I now have everything kind of simplified down on this side. This is a negative. I like those to be positives, so I'm going to add mine over to the other side. That gives me a positive 10 root 2m minus 1. Okay, took this, added it to both sides, got it over here. That gives me 24 left over, a 2m left over, and then I'm going to subtract 3 and subtract m. So subtract 3 and subtract m. That gives me 10 root 2m minus 1. 24 minus 3 is 21. And 2m minus m is just m. Now, I've got a square, so I need to go through that same step again and square both sides. Okay, so square both sides. Do you see how here where I squared it, I ended up with 2 of them? So I'm just going to go to that step and just say I've got 2 of them. So square this, it looks like I'm going to get 100 multiplied by 2m minus 1, right? 10 squared gives me the 100, and then square and square root cancel out. Equals, and then I've got 21 squared. Now, this is going to give me 441 plus, and then 21 times m and 21 times m is 42m plus m squared. Okay, and just FOIL that part out. Now I'm going to expand this bracket. So 200m minus, and then 100 times 1 is 100. I'm going to write my variables first and just tidy this part up. I haven't really changed anything here at all, just switched where the terms are. Okay, so m squared plus 42m plus 441. Now, same thing as before, I'm going to make this 0 on this side. So m squared plus 42m plus 441 minus 200m plus 100. So all I'm doing is I'm taking the 200m, subtracting it on both sides, and I'm taking the 100 and moving it over to the side by adding 100 to both sides. Okay, tidy this up. So m squared, and then I've got 42m minus 200m. Okay, so that's minus 58m. Sorry, 158m. So minus 158m. And then I've got 441 plus 100. That's 541. This does not work out nicely. Okay, but we still need to come up with roots for this thing. And so how do we come up with roots for something when they don't factor nicely? And the answer to this is we need the quadratic equation. Okay, so the quadratic equation in this case will do the trick, and if you don't remember it, that's okay. If we're solving for m here, m is basically equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And so I have an a term, I have a b term, and I have a c term. So I'm going to go ahead and just kind of plug these in and see what we get. So m is equal to minus a minus 158 plus or minus the square root minus 158 squared minus 4, and then a is a 1 and c is 541. So there's no way that I'm not doing this without a calculator at this point because the numbers are just getting too large. All over 2 times 1. So m is equal to 158 plus or minus the square root of, and then now 158 squared, negative 158 squared, is going to give me 24,964. minus 4 times 541, that's 2164, all over 2. M is equal to 158 plus or minus the square root of 22,800 all over 2. Now, here's where I can take a look at 22,800 and start to decompose this a little bit. So, 22,800 can really break apart. I see it ends in these zeros, right? So I know that this thing goes into 100. So 100 times 228, that'll work. And then I can break apart the 228, and I can break apart this into 10 times 10. 228 breaks apart into 4 and 57. So right away I can actually see that 100 times 4 can help me simplify this down a little bit. So really the biggest perfect square that it looks like this thing goes into, because 57 only really breaks down a little bit more into 3 and 19. So I have my group of 10 and my group of 2 that I can take out of this thing. So really the biggest perfect square here would have been 400. 100 times 4. And so 10 times 2, that gives me 20. So really the root of 22,800 can really be simplified down as 20 and then the square root of 57. So it can simplify quite a bit from where it started. So really this is just m is equal to 158 plus or minus 20 times the root of 57 all over 2. Now all of those are even numbers, the 158, the 20, and the 2, and so they can simplify a little bit. So 158 can simplify down to 79, 20 simplifies down to 10, 2 simplifies down to 1, and then I have 79 plus or minus 10 root 57. Here are my two solutions. So I've got one solution where it's 79 plus 10 root 57, and I've got another solution where m is equal to 79 minus 10 root 57. And what I would encourage you to do, just as an extra exercise, is to actually check this and verify that that works out. And I can tell you that it does. So a matter of plugging it in, I would just use decimals, and I'd plug in the values and check and see that it works. Okay, so yes, that one is a little bit more involved, but it's just a matter of following that logical progression. So there's a couple different parts that are here that are just highlighting some of the different notes to go through when solving equations, and there's questions that kind of come along with this. This is the last section before the unit test on radicals. So if you have any questions, do let me know, and basically once we're done practicing these, we're going to go through a little test review. So good luck.